Okay, YouTube, in this video we're going to be opening up a discussion about even and odd functions. Of course, our trig ratios are also referred to as trig functions, but essentially it is beneficial to know which trig functions are, say, even and which are odd so that we can evaluate them when dealing with basically negative angles. So we're not going to quibble too much about the definition of it, but I do want to share with everybody what is the definition of an even function, what's the definition of an odd function. So when we refer to an even function, we say some function f of x. You'll notice that what I've got right here is a negative input. Okay, so we say f of negative x. If it's even, what we do is we get f of x for an answer. So for instance, this is an even function. You know, we use this one in algebra all the time. This is considered an even function, but the reason why is because you'll notice that it wouldn't matter if I plugged in 2, I'd get 2 squared, I'd get 4. Or if I plugged in, say, negative 2, I would get negative 2 squared, which still gives me 4. In either instance, we could say, in general, if I were to plug in a negative x, look what happens here. I get negative x squared, which anything squared becomes positive again. I just get x squared, which in reality just means this. It wouldn't matter if you plugged in a negative here or a positive. You're going to get the same thing as f of x anyways. Okay, so a negative input, you could just basically, what even means is you could ignore it and evaluate it as if you had had a positive input in the first place. Okay. And odd functions. An odd function is any function that when you put in a negative input, what you're basically getting is the opposite of f of x. Okay, so opposite. Oh, my handwriting on this thing sometimes, I apologize. Opposite here, okay, of what I started with, or I get a negative f of x. So I won't go into an example of that one, but basically here's what I do want to point out. There are trig functions that are even and odd, and I list them here. We say cosine is an even function and sine is an odd function. So before I kind of go through this spiel right here, what I want everybody to know is this, and you should write this down. It means that if you were to ever take the cosine of a negative input, this is a function of some input here, some input angle. Since cosine is even, it's an even function, what this means is we could just do this as if it were a positive angle in the first place. Notice our definition of even says a negative input wouldn't matter. You'd get the same thing as if you had a positive input. So when it comes to us dealing with trig functions, it just means that we don't have to deal with negative angles anymore. We could just say the cosine of a negative angle would be the same thing as if you just did the cosine of the positive anyways, okay? And as far as like odd functions go, we say sine is an odd function. So in terms of how I would write this down, it means that if you ever take the sine of a negative angle, notice up here in our definition where the negative went, we said we'd get the opposite of what I started with, but essentially the negative was carried out front, and then we just did this again as if the input was positive. So basically, whenever you have a sine of a negative angle, you could just take this negative and throw it out front, and we could say it'd be really the negative of the sine of a positive angle. So what this does is it gives us an out. It gives us a way to not have to deal with, you can see in these two examples here, I don't have to deal with negative angles anymore because I'm already familiar with the nature of these functions, okay? Before I go into this really quick explanation, I do want to point some things out here. If cosine is an even function, secant is an even function. And if sine is an odd function, then cosecant is an odd function. I also want to include tangent and cotangent under the odd category, okay? So basically, again, if we said cosecant of a negative angle, that'd be the same thing as put the negative out front, and we'll just do cosecant of the positive angle because we like positive angles better. Or tangent of a negative angle, this would mean that that'd be negative tangent of the positive angle because it's an odd function. And again, secant, if we did secant of a negative angle, since it's even, we could just do secant of the positive angle here. So let's talk about why, and I give a couple examples here. Of course, we have our unit circle here that's going to help us out, and I've drawn one here, but what if I were to find, say, the cosine of negative pi 6? Now all this means is, it's like a negative 30-degree angle. It means that I'd have to spin 30 degrees in a clockwise fashion. I say, well, what's the cosine of this? I'd say, you notice here, I get root 3 over 2. I got root 3 over 2, and I wrote that here, root 3 over 2. But what if I had done the cosine of positive pi 6 anyways? If I would have gone up pi 6, you notice that I'm going to get the same x value regardless. They have the same thing. So if I have a choice, I would rather do cosine of positive pi 6 than cosine of negative pi 6. So again, since cosine is even, we could just make this positive. Since sine is negative, now I want you to see this, sine of negative pi 6, well, if I rotated pi 6 clockwise again, look at the sign by here, I get negative a half. I get negative a half. But what if I did the negative sine of positive pi 6. That is, if I were to go up pi 6 and say, well, what is the sine of this? Well, I get a half, but I say it would have to be negative a half in order to be equal to what the sine of negative pi 6 was here. But in other words, we took this negative and we could just put it out front here, right there, and we could do sine of pi 6. And the reason why I would rather do positive angles is because, again, when you list angles in the unit circle, you notice that all these radian or degree measurements, they're all positive. So now we no longer have to consider rotating in a clockwise fashion, okay? And this illustration just kind of points this out again here. If you had a positive theta or a negative theta, and you say, well, do the cosine of theta, and then do the cosine of negative theta, which is down here. We say it's the x value down here. You notice that you're getting the same x values. So the cosine of positive theta is really equal to the cosine of negative theta, and cosine's even. And we say, well, if I were to do the sine of positive theta, I'd get this y value here. And if I were to do the sine of negative theta, I'd get a negative y value here. Okay. So in other words, y and sine of theta, of course, are the same thing. Down here I got negative y. So in other words, sine of negative theta would be really equal to negative y, but that's the same thing as negative y is the negative sine of positive theta. So these two things right here mean the same thing. It just means that we can take this negative and throw it out front and just do a positive angle. So looking at these three down here just really quickly, let's tear them apart. We say sine of negative 60. Instead of me having to go up here and say, well, negative 60 is down here, nowhere am I labeling negative 60, we say, well, sine is an odd function. So what we'll do is we'll just take the negative and we'll just throw it out front. We'll just do sine of positive 60. And this is a lot easier because look, 60 degrees is right here. The sine value is root 3 over 2. So I would really just get this negative the sine of 60, which is negative root 3 over 2, which would have been the same thing. Look, if you would have rotated 60 degrees clockwise, you would have gotten negative root 3 over 2. But see, now we didn't have to think about a negative angle. Furthermore, looking at a cosine, oh, I love cosine because it's even. We'd say, well, then we could just do the cosine of positive 2 pi thirds because you're going to get the same thing anyways. We say, well, where is 2 pi thirds? Well, pi thirds is 60, so 2 pi thirds would be 2 60s. Here it is. We say the cosine of this is negative a half. So we could just use our positive angle now. And again, with cosecant of 225, cosecant is the reciprocal of sine. Oh, and by the way, sine is odd. So cosecant is odd. So this would be the same thing as the negative out front. We could put out front cosecant of a positive 225 degree angle. And recall that cosecant is the reciprocal of sine. So if I wanted to know this, I'd say, well, what's the sine of 225? The sine of 225 degrees, we could say go around 225. Here's 225. The sine is negative root 2 over 2. Okay, so if this is negative root 2 over 2, up here we're going to get negative the reciprocal of this. So we get negative cosecant of 225, which is negative reciprocal of this thing here, negative root 2, negative 2 over root 2, which is a positive 2 over root 2, which, by the way, we do want to rationalize. So that becomes 2 root 2 over 2, which is just root 2. But again, this just means we can deal with positive angles from now on, so long as we recognize which trig functions are odd and we can put the negative out front, and which trig functions are even and we can just neglect the negative.